So I'm going to talk about data science, and data science is part of the emerging technologies. There are maybe five, six, eight, and some people said about 30 new technologies in the next decade. So I'm happy because there are, every day I have new things or new toys to play with. So here's an example. Artificial intelligence, which I'm going to talk to you about AI probably next week or the following week, and then IoT, blockchain, and big data is the one that big data, data science, and so on and so forth. The one that we are going to talk. Automation, robots, and some of you are already familiar this in your companies. Immersive media when we talked about metaverse, and if you combine it with blockchain, Web3, you have all those new things happening right now. But again, when we talked about emerging technologies, it could emerge and then die. So yeah, it can be like a hype, but we're not sure about this. But these are the just technologies that are still emerging. Mobile technology, cloud computing, 3D printing, customer journey experience, energy technology. This is also very interesting. Cybersecurity, my field, voice assistant, nanotechnology, collaborative health tech, human computer interaction, and so on and so on and so on and so on and so forth. So there are so many things that we have to learn. Now, in terms of us, the nicest thing about Indonesia is the technology adoption is very, very, very high. Here's an example of statistics about Indonesia. There are 270 million Indonesians, and 77% of these 276 actually internet users. So you can imagine we have over 200 million, 200 millions internet users. So in the world, probably there are only, I guess, four countries that have the same size: US, China, Indonesia, and India, perhaps. So only four countries in the world. So this is very, very, very exciting. Although we still don't know how to manage them, right? So, but this is the reality. That's why it is important for us to actually able to manage or grasp with this new technology. Now, about data, I love statistics, especially numbers and things like that. And I'm trying to understand about myself. Now, when I play music, just like earlier before class, usually I played music. Those are the new introduction, and next week I'm going to increase the difficulties of the music. My music is kind of strange. The last video that I showed is actually me singing yesterday. I sang Mr. Roboto. I played in a quote unquote concert. I played three songs. One in Genesis, one was Mr. Roboto, and the third one was Disney. I see the light. So those kind of things. No, that's why I'm trying to understand myself. So every time I play a song, it basically I'm using a tool called Last FM Scrabble, so I understand what I'm listening. So this is an example of my statistics. This was taken a long time ago. I believe this was last year. But anyway, it says my music style. I love listening to rock, British pop 70s and so on, AOR and so on and so forth. And then the time that I'm active listening to my music is about this time. So you can see I'm an earlier person, early person. It's about 6 in the morning. I already play my songs, right, and so on and so forth. And also, it gives me statistic of persons who have similar interest, and also a person who have newer songs. So sometimes I click into this the list above me and to see what songs are they're listening to. So sometimes, oh, okay, they're listening to these new songs. Okay, interesting, let me listen to that songs, and apparently it's good because this is part of the statistic. That's why people talk about AI statistics. So that's that. Now, the thing about us is that human, we produce data, like quite a number of data every seconds. Now, with the rise of cloud, IT, and cell phone, I usually wear my mobile smartwatch, right? We generate lots of data daily. This is an example of statistic. I believe this was like 5 years ago. 5 years ago, there were already 75 billion devices connected on the internet. 75 billion devices for the internet. So the data the data that were generated by these devices and by us, they're kind of rising exponentially. For example, I earlier I just played futsal. I just came back futsal and then teaching. Right, I was very very tired now because I'm playing futsal for 2 hours. Right, and usually after playing futsal, we take pictures. So we take pictures, and usually I take five, six, seven, or whatever pictures. So something like this. I take pictures of my our team, and then this is just a small example. But if I take pictures like this, like probably it means nothing to many people, but to me, it means something. But I generated these pictures, this kind of pictures every day. So my problem these days is managing risk. Managing storage of my computer and my notebook. Lots of unused photos. I take pictures of my food and so on and so forth. I take junk basically, right? But that's what I do, and I am probably quote unquote still normal. And there are people who generated more data compared to me. They generated data like more 100 pictures every day, pictures of their food and so on and so forth. So yeah, so we generate this data, quite a number of data, and then this one like a posting WTF? Why is my LG washing machine using 3.6 gigabyte of data daily? So this is the statistic of his washing machine. His washing machine is using the internet all the time, except for this one, the dip. I don't know why. Maybe it's the power off. But the washing machine is giving data. What kind of data? Maybe it's listening to music or anything like that, right? I can believe this if this is actually your refrigerator. Maybe it's ordering milk, eggs, or whatever. Right? But this one is kind of strange. Okay. Now, here's another example that we are commonly used these days. People wearing smartwatches. I have my smartwatch. I have already have my this those that my watch is already my fourth or my fifth smartwatch. So when I was in Shenzhen like 3 weeks ago, I can see lots of watches. I just wanted to grab one of those and bring them home. But as you can see, this is just an example of devices that you can wear that you can measure your kind of the health of yours. For example, you can wear it as a headband, strap into your head, or straps into your whatever body part. Even shirt, you wear your shirt, and the shirt already detect your health. The wrist, you have smartwatches, clips. You put clips, and then inside your shoes. There's already sensor when you running. It will count how many steps, and then even distance and so on and so forth. And then there are applications that monitor you, like for example Strava and all those applications, right? I have my Huawei health. Basically, every time I walk and I check my watch. Oh, okay, I have walked, I don't know, 8,000 steps daily or whatever, right? So that's what I do, and these devices produces lots of data. Some of them may not be important. So that's why some people said the data is the new oil. To me, data is the new junk. We are producing junk every day. Most of these data are not important. So that's why we talked about big data. When we talk about big data, people always think about the size of only the size, right? The scale of the data, the size of data. We have 8 billion people in the world right now. Maybe half, I don't know, maybe half of them, it's already using the internet. So zillions or billions of data produced daily. So this is just one aspect of big data, right? The size of it. So we talked about the volume. There are five V's of big data. The volume is the first one. The second one, we call it the velocity, or the ability for us to digest the information. Like for example, I'm taking pictures daily. I have maybe every day, like I take more than 100 pictures every day, and I can only digest probably 20 every day. Whatever happened to those 80s, the rest of those 80s, I have it in my handphone, or I put it in my computers. Right now, my computers is already 96%. 96%. I don't know what to do. I have to copy this into my disk. I have external disks. I have already 7 external disks. Each of them, I think it's 2 terabytes. So I myself, like a personal user, I already have 14 terabytes of photos, music, or whatever data I produce. 14 terabytes. Can you imagine? It's just very, very huge data. Now, so the velocity of the ability for us, the ability of us, or we digesting or analyzing the data is usually very, very, very low. So the speed of data coming in is much bigger than the speed of us consuming the data. So that's what we call velocity, too fast. And then we talked about the variety of the data. When we talk about database, usually we talk about a field database, name, I don't know, salary or whatever, right? We have fixed fields and fixed data. But this time of the era, we produce many, many data in variety form. For example, we put our pictures in Instagram, so that's picture. We put all text in Twitter, so that's text. And sometimes we put pictures also, so that's text and picture. In Facebook, we talk, and then we put post pictures also, so that's a mix of and so on and so forth. So the type of data there varies. So so when we want to keep the data, what should we do with the data, because the format are very, very different. Now the value of the data, again, the value of data varies. We don't know whether my data is valuable. Maybe it's valuable for me, but it's not valuable for others. So if that data is gone or lost, maybe I might cry. I might cry, but I might not. But most people probably do not care about that. So the value is nothing. Why would we keep data that has no value? Because it's going to be a liability instead of an asset. So that's the thing about value. Well, we still don't know how to value the data, and sometimes if we know only certain amount of the data that we know. Now, every time I talk to some people, said, "Oh, what is your application valuable?" Oh, yes, pa, my application is very, very important. But I talked to another user, and she said that application is not important, pa. If the application is down, fine, it doesn't really matter, right? So again, the value. Who knows the value of the applications and the data? Okay. Veracity. Now, veracity refers to the correctness of the data. What if there are three different kind of data? For example, how many banks are there in Indonesia? And then some people said, oh, 170, and some people say 160, and some people said 180. I don't know the numbers, but it's just an example. Now, the number of banks is exact, right? How come there are three, four different numbers? So that's the thing that we have problems with this kind of big data, is the veracity. How do we tag uh, trust or correctness into the data? Because some of the data we don't know. Okay, so this is certainly this is a problem with big data. So that's what we have to deal with. That's what we have to deal with. Okay, now let's talk about data in sports. That's why I asked you to watch the movie. So this is about an example of data in Formula One. Formula One is one of those sports that data is very important. Like for example, McLaren. McLaren is one of the teams. They build race car. When they have race car, when they race, they make sure the data is correct, and all this data were generated by sensor. I can show you videos on the internet, on YouTube, many videos about data science at Mercedes and data science at McLaren. Here's an example. Now, during the weekend, because the race is usually happens during the weekend, there are more than 400 gigabytes of data generated by the event. That include the drivers, who are the drivers, the teams, the time, the tires, the pit stop, if the number of time, or also the number of seconds each team or each car goes into the pit stop and get refuel or tire change. So this is a problem, right? And then if you talk about the location of the car, so they have like a map here, and then they have the location of each car, GPS and all of cars. The resolution is centimeter. Can imagine if we have an application, right? If we order, say, GoFood, GrabFood, ShopeeFood, or whatever, right? Or we share our location to somebody through WA, WhatsApp, Telegram, or whatever. When you say it, it says accurate up to 14 meters, right? Or to 12 meters, or whatever. So the accuracy of our GPS is usually more than 5 meters. 5 meters usually. It's around 5 meters. But here in our sorry in our sorry in our sorry, hang on a second. Where's my mouse? Cannot see myself. Did you see my screen? No.
Not yet, sir.
Oh, sorry. Okay, hang on a second. How come? Okay, that's why I'm recording only myself. So I have to wait. So nobody said anything. Okay, let me just go back here. Yeah. So this is an example. Wait. I have to share the screen. That's why. Okay, this is my screen. So that's why the data generated by McLaren is something like this. Now, before that, this is the statistic of the washing machine, right? So I have to go back and show you all the images and the slides. Okay, don't worry, you got the slides. But anyway, here's an example of data generated at Mercedes and McLaren. You see the screen now, right? Okay. So
Yes.
here's this example of the GPS of the car. So the cars, they're accurate up to centimeter. So instead of 10 meters or 5 meters, the accuracy of the GPS is centimeter. So all this data is needed if they want to win the race, because they have to know the type of tires that they are going to use, whether hard, whether soft, whether they have to go to pit stop, and so on and so forth. So this is kind of very, very data oriented. It's very data oriented. So they employ many PhDs in Mercedes and also McLaren. The same thing, Mercedes, McLaren, all the teams. Okay. So data in data science in sports is actually a real thing. So this is about the Moneyball, and let's talk and move on to Moneyball. Um, Moneyball is a story about Oakland Athletics baseball team. This is a true story, and it is documented by Michael Lewis. Michael Lewis is one of those guys, one of those writers who are very good in storytelling. He has so many books. Probably you have read or maybe watched the movie The Blind Side. Sandra Bullock, right? So that's another movie. The Blind Side again. I think I have read most of his books. Uh, Few months ago, I talked about Going Infinite. This book is on cryptocurrency, the fall of FTX cryptocurrency. So this is a story about that. But that book, it was not very good, and I have to read this one. Premonition. I have this book. I don't have the time to read it yet. Liar's Poker. It's about a stock market and so on and so on. Now, what we want to talk about is the Moneyball. So if you have watched the Moneyball, this is about the Oakland baseball team in 2002 seasons, and the general manager Billy Bean, um, he has to compose a team, but the company or the team did not have money. So what did he do? So he had to recruit the teams, and he talked to Peter Brand, and Peter Brand apparently he's a geek who's very, very, very good in math and statistics. So they built the team. Now, Because of this, they're winning. They almost won the season. Because of this, the following year, every baseball team were employing data science because of these guys. Now, so this is just an example of the use of data science in sports. Now, another example also, the numbers data science is The Simpsons. The Simpsons is one of those cartoon. They have a very long series. I think it's more than 20 years, 20 series. The Simpsons. This is a popular cartoon about Homer Simpson and his wife Marge Simpson and their children, Lisa, and then Bart Simpson, and then Maggie. Okay, so the Simpson was very very good. But when you if you go through the Simpson, there are many mathematical or statistic secrets behind the stories. Apparently, the writers of Simpsons, they are very 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 good in math. There are so many math jokes. So there is even a book, The Simpsons and Their Mathematical Secrets. There is even a book by Simon Singh, and the story was very very funny. The Simpsons. And also another series is called Futurama. Same thing, similar to The Simpsons. It's they're great cartoons. I watched them a long time ago. Very 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 good cartoons for those who are very North American oriented. Anyway, so Lisa is a smart kid. She's very very smart. Bart is very very naughty. This is like a brat, very very his saying is very 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 basically rude. Homer is very quote unquote dumb. So sometimes what he says is very very funny. So Marge is basically she is the wife who's she's keeping everything together kind of. Now in the in season 22 episode 3, an episode called Money Bart instead of Moneyball. They said it Money Bart. This is like a pun, plesetannya Money Bart in plesetan dari Moneyball. So in this episode, Lisa Simpson was looking for extracurricular activities because there were alumni from the school, and they were from Ivy League universities. So they talked to Lisa, and Lisa asked, "How do you get into these Ivy universities?" And then they said, "You have to have extracurricular activities. You cannot just very good in math in classes, but you have to have extracurricular activities." So Lisa decided that she should coach Bart Simpson baseball team. The baseball team was called the Springfield Isotots. So now to do that, she learned sabermetrics. Sabermetrics is the metric or the science of baseball. If you look into the books here, the one that Lisa, the books that Lisa had, F equal MA. See, these are very, and then stats, and then this is Moneyball. See, that's the book of Moneyball, and then just physics, and then this one is Schrodinger's bat. The real word is Schrodinger's cat, not bat. So this is the plesetannya bat jadi cat, and then so on and so on. So this was a very very funny about how science or statistics into uh, sports. Tapi bentuk plesetannya. So this is more like a pun or parody of the episode. Okay. Even in soccer, also in football, this is a Liverpool Football Club. They employ uh, tactics and they employ statistics like this. So, for example, if you are number 24 and you have a ball, what should you do? You are, say, the blue team, and then you have to basically pass the ball. You have three options. You pass it to number 22, you pass the ball to number 26, and probably 26 can score, or you pass it to number 18. Depends on what you are going to do. So you can have statistic that says, for example, if you give it to number 22, then the possibility of scoring is higher if you give it to number 18, and so on and so forth. So if you pass it through like this, recently the UFAA, Carl Palmer, for example, he passed. He's from Chelsea, by the way, not Liverpool. He passed it like this, right? And the striker can score a goal. So they are using this in terms of football. Right? So you can have a look at this on the internet. Our links will be provided. So how Liverpool Football Club is using data science to dominate the world is in machine learning. So the point is everything the decision is based on data. The decision should not based on how you feel. Menurut perasaan saya, ya, you cannot do that. You have to have data to base your decision. Okay. And all over the world we had COVID, right? COVID is still here, but we already know how to manage it. But before, we did not know what to do when COVID hit us, right? So the easiest way was to make sure so to force everybody at home, stay at home, do not go out, basically stay at home. Now the problem with that is that economy will not grow or even die because there's no transaction at all. So you cannot put everybody at home. But how do you that? How do you restrict the number of people outside, and how do you allow people outside? So to decide that, you have to do some kind of numbering or measuring when and starting and the ending of what we call restriction, PSBB or handbrake or whatever you call it, but basically the restriction for people to go out, when to start it and when to end it. What aspects should we look for? Whether the number of patients, the availability of hospital beds, and so on and so on. Whether the economy is doing right, maybe people are not just dying, but people are very sick because of stress. They're staying at home, apartment or whatever, right? They stress at home because people get cooked up in very small places, and they have nowhere to go. So you have to consider everything about this before you're making decisions. I'm going to jump. I'm going to do that later on, but let me just jump to my slide. Hang on a second. Let me just jump to this one first. Okay. Let me just. Okay. Here's an example. I think there's an example of. I wrote this program, which basically take the data, and this was being used by many people to make decisions. I reported this to our the head of the region wise, the governor, West Java governor. So I put everything in YouTube and make it online. Here's an example of it. I hope you can hear it. So this is the statistic that I created. So I grab the data, scrape the data, and I look at the number of people who, when it's crossing, the number of persons crossing, and so on and so forth, and then the doubling and so on. So this is the rate. Okay, so I have lots of numbers there.
Selamat pagi, Assalamualaikum.
So basically, what I did is to create the data so that people or the government can make decision whether to put handbrake or not, or whether to issue handbrake or not. So they're looking at that. Oh, okay. So that's decision was based on data. Okay. Now, in terms of economy, now our economy is basically a different kind of economy. There's this good book by Professor Shoshana Zuboff, and the book is called "The Age of Surveillance Capitalism." So basically, she said that today our economy is based on surveillance. And then the surveillance basically is done by three or five giant companies, and mainly actually two, Google and Facebook. They're doing all the surveillance of our behavior, activities, and so on and so forth. We used to provide the data to these big companies for our own benefit. I will give you my data, but that's for my benefit, not for your benefit, not for your company, and not for your affiliation. So now the story is different. They get our data and they use it to make money and they sell it to other companies. So now the data, even we don't know whether we are providing our data voluntarily. So this is a problem these days. So basically, these companies, these big companies, created a surveillance around us. So an example would be Facebook long time ago with their issue with Cambridge Analytica, for example. That incident actually the one that triggered GDPR law in European countries. So what basically the idea is to put pressure to companies when they take data, our data, they have to be responsible. Otherwise, it's going to be chaos. Now, this book is very good, but it's difficult to read. There are videos about the book. There are interviews with Professor Zubov, and very good books. Like for example, she said, uh, you know, I don't know how many of you play Pokemon. I used to play Pokemon. Now with Pokemon, I go here and there to capture the, like the Pokemon, right? I go here and there. Now the problem with that is they're monitoring our behavior, and sometimes they directed us to go somewhere. Okay, there's this Pokemon. If you go to, I don't know, if you go to say to Burger King. If you go to Burger King, you get bonus or whatever, right? So basically, it is driven by us, the data, but in the end, the company actually drives us to do certain thing. They know our behavior. Like for example, probably tonight, if one of these companies may say, Pak Budi, do you want Fanta Merah? I can deliver it to you. I'm craving for Fanta Merah. So then already, okay, in front of my house, probably there's a bike packet or whatever, or food. You want to order martabak plus Fanta Merah, Pak Budi? If there's such a thing right now, I will buy it for sure. Why? Because they know our behavior. That's why when they said, I know how you will behave if you are voting. So this is an example of surveillance. Now, there is actually another documentary, a very good documentary. Why this is important on Netflix? There is a movie called The Great Hack, and this is very good. And why it affects us. So, but I'm not going to give you assignment for this. This is just for references. If you want to read, you can get many books, good books like such as this. But if you want to just know what it is, what the issues are, just watch this movie. Very good. Okay, so now we're going back to the real one. What is data science then? People talk about definition, about data science, this and that, and this and that. But the one that I like is actually this. This is a Venn diagram created by Drew Conway. So Drew Conway created this Venn diagram to describe what data science is. Let me drink my coffee first, so I can explain this one. Okay. Now, when people talk about data science, people are expecting one person to do the data science. But the idea of data science is not one person, but it is a team. So if you look into this, hang on a second. I have to get my tab to write. Okay. Wait, wait. I have my tab, but where's my connector? I have my tab here. Okay, tablet. Where's my connector? Oh, need to connect my so I can write stuff. Wait, where is the connection? Okay, my USB hub. Okay. Okay, it works. Yes, okay. Okay. So now we'll start with this. This is what we call a substantive expert, or we call it domain expert. Domain expert. Okay. So this is the person who understand the business process. For example, if we want to use data science in a e-commerce site, so this person is actually a person who knows the business process of e-commerce. If we want to use data science in, say, a law firm, then this person, domain expert, is probably a lawyer. If we want to use, data science in medical or medicine and whatever healthcare, so this is probably doctor or pharmacist or whatever. So this is basically what we call domain expert, the person who is involved with the business. Probably you are. So I'm putting you in this position as a domain expert. Now, suppose I am an owner of a pizza restaurant. I want to open. I have one restaurant, and then from one restaurant, I've got order using online services, Grab Food, Gojek, GoFood, Shopee Food, and based on that, I have the location of the callers. Now, I have money to open two new restaurants. Where should I put the restaurant? Now, before that, before the data science thing, what you have to do is you have to contact somebody who knows statistics. Okay, so you ask somebody who knows math or statistic, and then you do a traditional research. So the intersection between us and the expert is we're doing traditional research. For example, we create a survey, we send survey, we send to people, say, oh, okay, what is this, what is that? Where do you want to buy your pizza? When do you want to buy the pizza? Do you want to pay it by cash? And so on and so forth. So you create survey. So this is what was done a long time ago. Okay. So you have domain expert and then you have math expert. So that's one. Now, if this math expert, usually math expert, they know how to program, but sometimes they need more than just programming. So they need somebody who do who they needs more than one person or maybe one person who does programming. So this is a programmer or person who knows coding. This is an IT person. Okay, so this math person usually ask IT person, okay, can you write a code for this? I need to do I don't know, K means clustering or whatever for this data. I have the equation, but can you write a program for that? Oh yeah, sure, I can do it. So these days, this is what we call an AI machine learning is this part. So AI is basically an intersection between statistics, math, and computing programming. The thing about Drew Conway talked. He put the name of this. He called it hacking skill. Some people got mad because hacking skill. It seems like bad things. No, no, no. What it means is a person who knows how to code. In other more formal setting, that section is called computer science or IT. But I love this Drew Conway because in reality, when you want to have somebody to do coding, it doesn't have to be a person who has IT background. Sometimes you have, in my team, for example, there's a person from astronomy. I know a person who very good in coding from geology, even from arts department. They're very, very good in coding. So that's why we need them in this section. Okay. Now the problem is when when you are as a domain expert and you want to know something, you just hire a programmer directly. So you have the programmer. Can you do this without knowing the math or the statistic? This is what we call a danger zone because it can lead to something that is unpredictable. So I'll give you an example about this danger zone. You have an idea. You have an idea of what data to get, but you don't know the real math, and then you just need somebody to code it for you. So here's an example of like a joke, basically. This is from a data science joke from Dilbert. So this is the boss, the domain expert, and he wants to get the size of the market. Hey, use the CRS database to size the market. So he asked Dilbert. So this is an IT person. This is the boss, right? And they said, boss, that data is wrong. And we cannot use this database because that data wrong. Okay, so the boss said, then use the SIBS database, the SIP database. And Dilbert said, that data is also wrong. Okay. So the boss said, "Can you average them?" Okay. Gilbert said, "Sure, I can also multiply them too if you want." So this is something, in bahasa Indonesia, the joke is something like this. Orang bisnis, carikan data pendapatan penduduk Kota Bandung dari BPS. Pak, data BPS tidak akurat, Pak. Oh, kalau gitu cari data dari pajak aja. Datanya tidak akurat juga, Pak. Oh, kalau begitu gimana kalau kita rata-ratakan? Kalau saya kalikan juga bisa, Pak. Mau saya kali, bagi, pangkat juga bisa, Pak. Terserah Bapak. Tapi kan ini maksudnya apa nih? Dia nggak ngerti business process, so he doesn't understand the business process. So the joke is if you have a person here, okay, and that person, this is danger zone, right? That's why you need somebody in math. Now, data science is the intersection of all of this. So this is what we call data science. A team of persons who know the business process, who knows some kind of statistic math, and who knows some kind of programming. So this is data science. So this is actually a team, not a person. But sometimes people want you to become everything, like a Superman, everything. So it's not going to work. So that's why in this class, you are here. So I'm going to teach you this part. I'm going to teach you this part, but I'm not going to turn you into a person who knows everything about IT. No, no, no. That's not my point. My point is to get you understand this. Yeah. So when you hire somebody, what they can or cannot do. Okay, can you do this? And the person said, no, I cannot do it. And then you can say, yes, you can. I've done it before. I think you can. You just have to do it this way. Okay. Then you let him do it. Okay. So and then I will teach you a bit about statistic, not much, maybe one, two statistic. It's just an example. So you are still here, but you understand this, a little bit about this, a little bit about this. So you know a bit about this is science line. So that's the
That's my
goal.
problem, Pak.
That's your problem. Okay.
Yeah. I have I have in my mind I have this kind of project about like this is but when I met the developer I don't know how to
Right.
translate this into
Idea.
their
Right, right,
language.
right.
Yeah.
Yeah, yeah. So that's why usually you go through this person, this the math, the modeling person first. I need to do this. How do you do that? And then the math person will say, oh, okay, you can do this, and with this data, and then do this, and then okay, let's find somebody who can code that from our database. So yeah.
Yeah. After the web developer say like technical language
Yeah, yeah.
and then I become lost.
Yeah, yeah. So, for example, I need to have access to, I need to get data where the places where our customers are from Indonesia or abroad. And then the developer will say, oh, yeah, I can see from the Apache log, I can see the data. And you just got lost, right? I don't know what Apache
Yes.
is. What is log? What is
Yes.
this, right? Yeah, yeah, yeah. So, yeah. Yeah, so the data science actually helps you to understand very many point of view. So that's the whole idea. But you still going to be here, right? Don't worry. So this is a more formal definition of the data science, but I like this because it's informal. This is exactly what it is. But you have a formal domain business knowledge, okay, math and statistic, and here they put computer science and IT. So this is data science. Yeah. So this is the more like this one is a software development instead of danger zone. Yeah, but so that's this is the formal definition. Okay, now let's go back to this data science Venn diagram, right? Now you are here, and then now these days there is a trend to teach you how to do some kind of understanding the coding using what we call low or no code tools. So basically, you put the data, and then it will produce whatever you like or whatever you ask. That's wrong in my opinion because you have to understand also some sort of coding. So in my class, we are doing a bit of coding, low level coding, so you understand what's going on. So when you're given this kind of tools, you know what's going on. Okay, it's just like understanding math, and you're given Excel or spreadsheet, and okay, I can use spreadsheet to do this because I know math. I have to I have to add this, I have to divide that by that column, so you know that, right? So now there's a trend to do this, and then also there's trend to do everything by artificial intelligence. Let's do with this with AI. Let's do this with AI. So that is it. In my opinion, that is wrong, right? Not everything can be done with AI. AI is just an kind of an intersection between math, science, and coding. Okay, so this is what is happening these days. You'll see lots of products that were advertised as no code tools, AI, and so on and so forth. But you still need a team to manage all of that. Okay, so okay, now the there are many data science tools. So we are swamped with all kinds of those. What do we do? Okay, now first thing first, the data they're available in all kinds of formats. Sometimes in a database in a column format. Sometimes it's in our spreadsheet in whatever format, Excel, CSV, text, or whatever, and sometimes in JSON, XML, even free format. For example, if we want to analyze, say we are a business owner or Airbnb, for example, we are analyzing Airbnb data. What do people look when they want to book a house or a place in Jogja area, for example? Do they look for a kitchen, or do they look for food? Do they look for because of the data, lots of data, and most of this data in free format. So that's why we have to get into their comments and things like that, and then parse them and try to understand those data. So this is just an example of problem. Okay, the format are different, so many formats, and then based on that those data we have to what we call wrangling the data. We want to manipulate the data so it's easily interpreted. We want to visualize them, so we can get a grasp of what is this. And then the data also sometimes in text format, and then sometimes it's in binary. For example, you have the data, but there are pictures of persons taking selfies in hotels or whatever. Are they happy when they're taking selfies, or are they mad, and or are they posting good stuff from the hotel or bad stuff? This is what we want to know. Okay, so that's that. Okay, now to do that, usually there is some kind of visualization to get an idea what our problem is, to get an insight what it is, and then probably remove attributes that are not needed. So this is just an example of what we are doing now. The phases of our analysis, usually there are many phases. The first type, the one that probably we're going to see, is to describe. We have data. Now we want to describe what is this data. So this is kind of a snapshot of current situation, or snapshot of a data, whether that's live or that's an old data. But basically, want to describe. The idea is to get insight. What's going on? Okay, so this is what's going on. Just to get an insight. That's it. So this is the first phase, and then based on this, you want to diagnose. Okay, so I have this data, but maybe I don't need those data. I don't need this data, and so on and so on. Again, you can simplify the data. Okay, now I understand what's going on. So we are trying to diagnose. We want to find the root cause. Okay, uh, based on this, then we can predict the future and do some kind of prescribing, or what we should do, and so on and so forth. But this is more involved, and I don't think we have the time to actually go through all these phases. Maybe what we are going to do is we're going to follow the theory and practical labs up to this point described. Okay, so that's what we want to do. We want to visualize things, and then later on we can do what if scenario. But at least we know the data, and we're going to do some kind of programming to do that. Okay, now people are talking about AI, but what we are doing right now is data science. Okay, now data science is we are using statistics or math to find model. Basically, we find, okay, this is our model. But in machine learning, they're not using statistic or math in per se, but they are using example. So we give them, this is example number one, example number two, example number three, example number 5,000, 5,001, 5,002, and so on and so forth. So basically what they're trying to do is they're trying to find model based on examples, not based on a statistic of or math. So sometimes this is good and sometimes it is bad. Now, this is good because sometimes we don't know the math. We don't know the statistic. But this is bad if we give them examples, bad examples, examples that do not represent the real data, and examples that are biased. When we learn AI, maybe next week or the following week, I'm going to show you what I mean by bias in AI, the bad thing in AI. But people are using AI because sometimes we don't know the model, so that's why we're using AI. Now, in data science, we are involving expert, which means human to predict. So that's why we have this class and so on, so forth. But in AI, we want to reduce the human. We want to reduce him. We want to automate things. No human. Okay, no human. Automate. Basically, we want to have a machine that does many things. So this is basically the fundamental differences between AI and data science. Data science is still important, although we already have AI. I'm going to teach you AI next week on 2 weeks, but right now we are going to focus in this side. Okay? So don't worry about all the hype in AI because we are using. Can we drop in and replace that with AI? Yes, we can, or sometimes we cannot. But you have to understand what's going on first, so that when you use tools, yeah, it's just tools. Now, the tools that we're going to use, there are many, many tools, but we're not going to use all the tools. The first one, we can have data. What format data? What format or database or storage that we use to store the data? Sometimes we store it in like a folder. In the folder we have lots of text, images or whatever, right? We can do that. Maybe docs or whatever, right? We can have that a folder with everything, but that's unorganized and it is difficult to process. Now we want to store this in more proper way so that we can access them easily and faster. So that's why we have all kinds of database. For example, we have MySQL, MariaDB, Postgre, and so on and so on. And if you have these are more like a formatted database with languages, SQL to access those database. So it's more like a standard way to access database. But you can also have free format database. That's why we have MongoDB. It is free format database. And other than this, we have also all commercial applications. For example, database. There's Oracle. There's DB2. There's Microsoft SQL Server, and so on and so forth. But basically, there are many, 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 many databases and system to store the data. Now, there are commercials and there are also open source and free database. Open source and free is not always bad. Some of them is actually pretty good. MySQL used to be the kind of the de facto database for experimentation because it's freely available, open source, and so on and so forth. But now MySQL has turned into more like a commercial section. Now it is replaced by MariaDB. MariaDB. This is basically the same thing as MySQL. Postgre is developed by CMU and so on and so forth. But basically, you have all the data in some sort of database. There's probably later on there's Elasticsearch, Elasticsearch. Once you have the database, you have the data in your database, you want to transfer this data. For example, I want all the data in one table. I want to combine those tables, make it easier. And I want to combine this and that, multiply this and that. So that's why you want to transform your data. You want to process the data. So there are many tools to do that. And one of those is Python. So this is what we're going to use. That's what I'm going to teach you how to code in Python. The reason I want to teach you Python because Python is a versatile language. It can be used for data science. It can be used for creating music. It can be used to IoT programming. It can be used to in AI. It can be used in all kinds of generic programming. So Python is actually a special purpose. It's not common purpose programming language. Okay, so that's why instead of learning many things, let's just learn one thing. Now, again, in data science, we want to have model, right? Once we have all the data, we have all the tools to manipulate the data, but we want to create a model using some kind of math statistic. What do we do? Well, we have so many tools inside this. This is an example of NumPy, Pandas, Matplotlib, uh, and so on and so forth. These are what we call Python modules. Python modules. Those are libraries that we can use to draw graph and so on. We're going to use this as a replacement, say, for Excel. We are replacing a spreadsheet using Pandas, Matplotlib to draw charts and so on using Python. So that's why in this we are using Python. In model, we are using Python. Now, once we have the model, we want to visualize it. We want to see that the diagram, the graph. There are many libraries or tools to visual them. Like this Matplotlib with one of them. Again, these are libraries that can be programmed through Python again. So we have all kinds of tools available for us to visualize the model using Python. Now, when we talk about high performance data science, then usually we have some sort of queue and to make it scalable. So we have Kafka, RabbitMQ. These are just basically queue. Now there are many other tools, but we are not going to use them. Even just introduction to them is already time consuming. So I'm going to pick something here. This is going to definitely about Python, and we're going to use Python libraries, and we have to. I think I'm going to stick with Matplotlib to do some kind of visualization here. We're not going to have time to do performance and so on. So this is what we're going to do in our limited time. Okay, but don't worry about this. And then there are list of other tools, but you don't have to know all of them. My way of learning is to use things when we need it. When we need it, we learn it. If you don't need, you don't have to learn. I don't have to learn it. Okay, so that's my way of learning things. Yeah, just good enough to get by. So that's what we are going to do. Lots of tools there. I'm going to skip them. Okay. Yes.
Sir,
Yeah.
how about Power BI? I think it's quite popular in my
Yeah.
office right now, Power BI, to visualize data.
Yeah. Yeah. There's also Tableau. There's also there are many specific tools for specific industry, and some of them are expensive. Yes. Definitely Power BI, Tableau, and other kind of tools. Yeah, they're being used, and R programming language is being used. But the thing is, we don't have time to learn all of kind of tools. That's why I'm going to teach you just one thing, Python, and you can use Python to this, that. Python can be used for everything. Okay. Yeah. So later on, when we use Python, I'll show you how to do things in Python. So you can use Python to get data from a server, process it here, display it, visualize it, and do some kind of what if, save it into presentation material, and so on. You can do that. Yeah. And there are also not system, but companies that are hosting tools to manage all these tools are in one kind of one platform. You go into this platform, you log in, and then you can select this and that. All the tools are already there, so you don't have to install this and that. Orange is one example of them. You go to log into account Orange. Snowflake is another example. You go in and then you play with these tools. It's already pre-installed there. All you have to do is bring your data and manipulate your data and trying to get model, visualize it, whatever. Everything is already there. Now, what my way of doing this is more like the hard way of doing things. I'm not going to make you easy to understand this. Okay, because it's going to be the hard way of doing things. Yeah. So yeah, here this is another example. If you look into many educational sites, online educational sites, Datacam, Udemy, and things like that, you'll see that Python for data science. You'll see, like advertisement, something like that. No experience required, 90 hours of learning. But we're going to strip it down into one or two classes. You get the idea. Now, the programming language, you have S, R, but then you have Python here. Generic programming language, we have Python. Data visualization is they have Python. So that's why we are using Python, because it can do everything. Okay. So instead of learning S, R, other kind of languages, just learn Python. Okay. Now, in terms of statistic, I don't think I have many time, but probably I'm going to talk about linear regression and do some coding, and also maybe k-means. It all depends. Or k nearest neighbor. I don't know. Maybe k-means. Okay, k-means clustering. Maybe. Okay. Okay. Talked about that. Now, my point is data science is a field which requires people with all kinds of academic background, not just one. So that's why it is a team, not individual. So the thing is, are we ready or not? So that's my presentation. If you have any questions, now it's time to ask the question. Let me just pause the